We'll get started with our first project very soon, but before we do, I want to make sure that you have a solid grasp of what Electron is, why we use it, and what some of the advantages of using it are. So first, what is Electron? What is it really doing for us? So let me give you a plain, simple English definition. Electron is a platform for writing desktop apps by using tools, languages, and design patterns traditionally used for creating rich apps on the web. So you might ask yourself, well, why might we want to use web technology for building desktop applications? And that's a really good question. That kind of cuts right to the heart of the matter. So let's do a little bit of background and figure out why we might want to use web technology for building desktop apps. Over the last 10 years or so, we've seen an explosion in the complexity of applications created for use online. So there's applications like Facebook, LinkedIn, Google Inbox, Google Maps, and a multitude of other products that are incredibly complex pieces of software working inside of your browser. Over time, we've begun to replace traditional desktop applications with complex web applications instead. Web applications have some marked benefits over traditional desktop apps, which we're definitely going to discuss a little bit more on later. At some point in time, someone said, gee, working with these complex web apps sure seems to make life a bit easier in some regards, or more convenient, if nothing else, than producing complicated desktop applications. So why don't we just use the web for everything that we do? And so that attitude has led to this increase in complex web applications. There is one very strong technical shortcoming to running applications in your web browser, however. So they're not a catch-all, it's not a perfect solution per se. All these applications that run in your browser, whenever you use your browser to go to some fancy website, are all limited to executing inside the context of the browser, which places some strict limitations on a website's ability to access the user's underlying operating system. So this means that certain methods of input and output are constrained in the browser. So google.com right here, or linkedin.com, or facebook.com, for example, it can't access your hard drive. It can't access a lot of lower level features of your operating system. So desktop apps aren't entirely out of the equation just yet. There's still a need for desktop apps for some types of applications. And so we're left with Electron. Electron allows us to build websites that run on a user's machine with a higher level of operating system access than traditional websites. But they still retain a lot of the benefits of web technology, such as speed of development and familiar tooling. Okay, so that's my soft intro to Electron, but mostly it's a lot of marketing buzzwords and mumbo jumbo like that doesn't really tell you a lot about what's going on behind the scenes. So let's take a quick break, and then we're going to come back and start diving into the technical aspects of Electron. So I'll see you in just a second. Hello and welcome. I'm sure you're really excited to get to the Electron side of this course, but before we dive into any technical details, I just want to cover a quick few points. First, how to get help in this course if you get stuck. This course has a lot of pretty complex code and a lot of, well, we'll say interesting areas, interesting pitfalls that you might fall into. So I totally expect that you might have some questions for me at some point during the course. Always feel free to reach out and ask for help. The best way to get help from me is to either post directly on the Udemy discussion forums, let's spell that correctly. You can send me a private message on Udemy. And if you have any really quick, just one-off questions or just want to talk at all in general, you can always reach out directly to me on Twitter. If you ever ask for help in any form, it's really nice if you can send your code or post your code on GitHub ahead of time and then link me to your repository, because I'm usually going to want to see your code. It makes it a lot easier for me to figure out what's going wrong if you need some troubleshooting. If you don't know how to use GitHub or post your project as a repository, no problem. You can always just post the contents of individual files on, say, the Udemy discussion forums or in a private message. You can always just send me the contents of a particular file directly to me. But all that's really important is that you kind of share a little bit of code with me, because it does make the troubleshooting process much easier. Okay, so that's it for preamble. I'm pretty short on preamble. I'm way more about technical topics. So let's continue in the next section, where we're going to start to dive directly into Electron and figure out what it is and what it does for us. In the last section, I gave you a soft introduction to Electron. Remember, Electron is a platform for creating desktop applications while using familiar web technology tools. In this section, we're going to immediately dive into some of the details of Electron and get a better sense of how it works internally. After that, we'll discuss a little bit more about the history of Electron and then move towards working on our first project. So let's get to it. So again, in this section, I want to talk to you a little bit about how the internals of Electron works. And we're going to do so by looking at a very familiar piece of software that you might already have installed on your local machine. Okay, so here's my claim. Electron is almost identical in its internal workings to Google Chrome. And do notice the qualifier down here, mostly they're the similar. So in this section, we're going to look at how Google Chrome works internally, and then we're going to try to move all that understanding of how Google Chrome works over to how Electron works internally. Now do keep in mind that as we're talking about how Electron works internally and how Google Chrome works internally, I really am talking about the internal, very internal workings, like the inner gears and the inner code that's working inside of Electron. I'm not necessarily talking about how you and I write code for Electron. So I just want to kind of quantify or clarify that point. Okay, so to demonstrate a little bit about how Google Chrome works internally, give you a better sense of what it is doing, I'm going to open up two programs on my local machine. I'm going to first open Google Chrome, of course, and then I'm going to open up the activity monitor as well. Oops, activity, there we go. Okay, so I've got Google Chrome open, there it is right there, and I've got my activity monitor. If you've never used it before, the activity monitor shows me all the different running processes that I have on my local machine. If you're on Windows right now, you can always pull up the task manager as well and check out the running processes that you have on there too. So in my activity monitor, you'll see processes like Atom, there's my code editor. Here's Balsamic Mockups, which is what I use to make diagrams for this course. And if I scroll down a little bit, we will come across Google Chrome right here. So immediately when we look at Google Chrome, you see not only Google Chrome, but you also see this collection of Google Chrome helpers. Well, that's kind of interesting. What in the world are Google Chrome helpers? Let's investigate what these things are. Let's get a better sense of what a Google Chrome helper process is. And do remember, as we're walking through this, the entire point of looking at Google Chrome is to get a better sense of how Electron is working as well. So I just want to remind you that's what we're attempting to accomplish here. I'm going to go back over to my browser and I'm going to open up a couple different tabs, and inside of each one I'm going to navigate to google.com. So I'm going to get about 6 or 7 tabs or so. That should be good. Now I'm going to go back over to the activity monitor and I'm going to look at the running processes that I now have. So after giving it a few seconds to update, you're going to notice any second here, there we go, a handful of additional Google Chrome helpers were just created. You can see them all listed here. Again, there's about 6 or 7, one for each tab that I just opened. So what is Google doing here? What is Chrome doing here? Why is it spawning all these different processes? Well, let's look at a diagram. Okay, so when you start up Google Chrome and you see inside of your activity monitor a process called Google Chrome, we can refer to that as the browser process. That is the process that runs the actual window that runs Google Chrome, like this actual physical window, like the whole big outlines, the thing that shows the buttons here at the top left, the thing that shows the menu bar at the top, all that different kind of stuff. On the other hand, we have these individual tabs, which we refer to as child processes, or processes that are intended to just run a single tab inside the browser. So why might Google Chrome choose to architect their program in such a fashion? Why might they choose to have one process for the overall browser and then one process for each of the different tabs that we have opened? Well, Google Chrome decided to architect the program like this to have better encapsulation of each tab. So if one tab opens up, let's say that I open up this tab right here, and maybe the rendering engine used by the browser has some big security issue or some big rendering issue. The idea is that by isolating each tab into its own separate process, we isolate its ability to affect the overall operating system or overall other tabs that are running inside the browser as well. So it's really being implemented from a security standpoint and a functionality or essentially bug resilience standpoint as well. We refer to those child tabs either as child browser tabs or as renderer processes or a renderer process. So we have our overall Chrome application that spawns all these different renderer processes, each of which shows some web page. Okay, so you're probably sitting here thinking, Stephen, how again is this all relevant to Electron? And hey, bear with me here, we're getting to the point. These separate processes that we create, or that Google Chrome creates, I should say, are so separate that they don't have the ability to directly talk to each other or communicate even with the overall Chrome application. Instead, they communicate through a system called inter-process communication, or IPC for short. We're going to see IPC and this idea of separate render processes come up again and again as we are working through Electron. So at this point in time, you really probably are thinking, okay, Stephen, this is all great. Thanks for the review of how my browser works, but what does this have to do with Electron? But that is the point here. Electron works identically to how your browser does. Surprise! Under the hood, Electron makes use of the Chromium open source project, which is the exact same codebase that the Google Chrome browser is based upon as well. So when we work with Electron, all the same rules and conventions of how Chrome works applies directly to Electron as well. In an Electron app, we are going to create an object or a process that spawns one main window, and that is going to have some number of child renderer processes as well. The purpose of each of these render processes in our Electron application is to show a separate window to the user in a sort of desktop-looking environment. Our Electron app can have as many running render processes as we wish, each of which show a separate window to the user. Communication between each of these windows is going to be handled by that same IPC or inter-process communication system as well. So remember, at the end of the day, whenever we are making use of Electron, we can really think of it as working identically or the exact same as our Chrome browser does as well. And this is really important to understand because behind the scenes, you're going to notice some really weird ways in which we're going to interact with Electron. The reason I'm showing you all this is to give you a little bit of backstory, a little bit of sense of why we are interfacing with Electron in sometimes what might seem like a kind of odd fashion. Okay, so last thing I want to say about Electron for now. So you might be used to developing apps for the web. So whenever you're making websites or web applications, you can kind of imagine that only the stuff inside of the body of the browser, like this content area right here, is fair game for us to mess around with or to show content or to handle events or stuff like that. When we start to use Electron, however, I want you to start to imagine that we are now developing for the same environment, but the big change is the area that we have to affect with the code that we write. With Electron, our fair game extends to the entire browser window. So we are no longer being limited to just the content in here. We get to have access to absolutely everything that makes the browser the browser. Now that might seem like kind of a weird comparison to make, but again, trust me, when we start working through Electron, having these kind of distinctions or this thought process is going to start to make life a little bit more easy. Okay, so now that we've got a slightly better sense of what Electron is doing behind the scenes, let's continue in the next section where we're going to learn a little bit more about the history of Electron. So I'll see you in just a second. In the last section, we spoke a little bit about the internals of Electron and how it's very closely related to the Chromium and Google Chrome projects. Remember, when we're working with Electron, you can essentially imagine that we're working with the entire Chrome web browser. We will create one main process, and then we will create separate renderer processes that are used to show content in an actual window. Let's now continue by looking at the history of the Electron project a little bit. Now, in all my courses, I normally do not dive into the history of a project. I'm way more focused in just learning, hey, how do we use this thing? So for example, I don't really ever talk about the history of React in my React courses. I just say, hey, here's React, let's figure out how to use it. Electron is a little bit of a different situation, however. With Electron, understanding why it was created in the first place is absolutely key to understanding why Electron behaves like it does, and even why it's based on Chrome at all. Understanding why it was created will give you a lot more insight into the technology choice and the design methodology behind it. So, where did Electron come from? Electron was made by the company GitHub back in 2013. Electron was then used to create an open source code project, or an open source editor, called Atom, which was then open sourced in 2014. Now, I want to tell you a little bit more about the company GitHub to help you understand why they chose to make a code editor at all, and on top of that, why to base a code editor on top of the Electron project. Now, I am going to preface this by saying that I do not work with GitHub and I did not consult with them over what I'm about to say. These are my own personal beliefs on exactly why they created Electron and why they created the Atom code editor as well. Okay, so this is my belief on GitHub's thought process, essentially why they made Atom and why they made Electron. At their core, GitHub is a company involved in the management of code, not the creation of code. Remember that GitHub is based on the Git version control system, which is used to track changes in code, merge different blobs of code, and review changes in general. So it's a system that is used after the fact, so to speak, of the code writing process. Now, I personally imagine that someone at GitHub said, it's great to have a total lock on the code management process, but from a business standpoint, it sure would be nice if we could somehow get involved with the code writing process as well. And so to get involved in that code writing process, they said, hey, let's make a code editor. Sure, that makes a ton of sense. So they then sat down to make a code editor, and they clearly wanted to bring some of the same conventions of GitHub over to this new application. Remember that GitHub has a tagline of quote unquote social coding, or coding that can involve many different parties of people reviewing and contributing to a single code base. So they clearly wanted to bring that same type of social aspect over to this new code editor as well. In order to allow more people to contribute to this code editor, they wanted it to be written in a language that was easily accessible to the majority of their customers. So they wanted to make sure that it was written using a programming language that all their existing users would feel really familiar with, so that they can encourage their users to contribute to and improve their code editor. So when we think about the different languages that GitHub makes use of and what the most common language on GitHub is, well, far and away, it's JavaScript right here. So this is github.info. It's a website that tracks different languages that are in use on GitHub. And you can plainly see JavaScript has about 323,000 unique repositories that make use of JavaScript. The second most popular is Java at 222,000. So GitHub decided to write their new code editor using JavaScript, with the intent being that it would be easy for their most common users to extend the editor by writing plugins or submitting patches or features. And so Electron was born. After deploying Electron in Atom, several other companies said, wow, looks like there's actually a lot of benefits to treating our desktop applications like a web application and using web technologies to create them. And so they jumped on board and essentially jumped on the bandwagon. And that's pretty much what leads us to today. Again, the reason I tell you all this is to share a little bit on the backstory of Electron. Understanding why JavaScript was chosen for this platform is important for understanding some of the ethos and design philosophy around Electron apps. And we'll certainly discuss more of those aspects as time goes on. Okay, so at this point, we've now had several sections of lecturing and backstory about Electron. I think that we're now at a pretty good point to get to start working on our first application and really get our hands and sink our teeth into Electron and figure out how to use it. So let's get started on our first project in the next section.